Okay, we are going to be talking about finding vertical asymptotes of a rational function. And this will be in a few parts. And the first one will be just illustrating and defining what it means to be a vertical asymptote. So first of all, let's let f of x be our rational function. So it's equal to p of x over q of x not equal to 0, where p and q are both polynomial functions. That's what it means to be a rational function. And let's let h be a constant. Okay, first of all, let's see what that means graphically. For the sake of this illustration, let's let h be equal to 2. Okay? If we were to, so what would a vertical asymptote look like? Well, would be we're going to draw it as a dotted line here at x equals 2. Okay, and so my function will be approaching this vertical asymptote from the left or the right or both, and it would either blow up towards that asymptote, or it'll come down towards infinity as x approaches 2. It could do it also from the left, from the right, and it could have that's kind of a picture of what it could look like. Okay, so let's actually put some math ease to what I'm saying here. So notice on one example I was coming towards that asymptote from the left, and in the other example I came at it from the right. And so we have a way to express that. So let's define what this means. If, as x approaches h, we'll start from the right. If as x approaches h from the right, my function goes either to plus or minus infinity, or if as x approaches h from the left, f of x approaches plus or minus infinity. If either of those cases are true, then x equals h is a vertical asymptote for my function f. Okay? So that's what it means to be a vertical asymptote for this rational function. Okay? Now what I'm going to do here is I'm going to kind of talk about what that means to come at x from the left or from the right. Okay, so in the first, let's look at x approaches, and again, let's let h be equal to 2 in this example. As x approaches 2 from the right, what does that really mean? Well, now we're looking at values such as 2.01 or 2.001 or 2.00001. So I'm getting closer and closer to 2, but I'm always slightly bigger than 2. So that means I'm coming towards 2 from the right. Okay? And in that case, perhaps my function blows up towards infinity, in which case we have that example. Or perhaps as x goes to 2 from the right, my function gets larger and larger negative, in which case we have this illustration down here. So what does it mean to approach it from the left? So as x approaches 2 from the left, we're now looking at values such as 1.9 or 1.99 or 1.999999 and so on. You get the picture. So we're getting closer and closer to 2, but this time we're slightly under 2 or less than 2. We are approaching 2 from the left. If, when doing so, my function blows up towards infinity, then I have that particular example. If, when approaching 2 from the left, my function gets larger and larger negative, then I have this example right here. Okay, in all of these cases, x equals 2, which is a vertical line, x equals 2, would be a vertical asymptote for my function f. And that's how we define a vertical asymptote.